Thanks for the introduction. Greetings all and welcome to yet another informative webinar hosted by Multotec. So when Multotec asked me to give this presentation, I was a bit overwhelmed. Not for lack of the subject matter, but rather trying to decipher how to focus the content that will be relevant to everyone while sticking to my strengths in minerals processing. The outline of my presentation will look at a brief overview of Mintek, where I work, some of the challenges that the mining industry is facing, which necessitates innovation, the drivers of innovation and the need for change, the intrinsic relationship between research, technology, and innovation, the different types of innovation and how you go about implementing innovation within the three specific disciplines in minerals processing, as well as the related challenges. So mineral processing strategies in relation to research activities being undertaken at Mintek. And lastly, how to improve on building an innovative culture and some of the lessons learned. So Mintek was founded in 1934. We are now 89 years old, and we are South Africa's premier national mineral research organization, hosting one of the largest mineral processing and metallurgical test facilities in the world. We work closely with research and development institutions, industry, and OEMs like Multotec and others for providing process development and optimization, service test work, consulting, and innovative products and services to clients worldwide. We can execute all scales of test work to support scale-up studies and techno-economic evaluations, from early-stage, small-scale exploratory research to very large, continuous pilot demonstration scale. As can be seen, Mintek operates towards the latter stages of the mining value chain, right up until value addition. So we have expertise facilities and top-rated, highly qualified researchers in minerals processing, known as concentration here, hydrometallurgy, biometallurgy, pyrometallurgy, mineralogical characterization and assay, as well as further refining through our advanced materials division. My talk today will concentrate on the minerals processing division reflected as concentration in this diagram. The mining industry is facing a confluence of challenges necessitating the need for continuous innovation to enable sustainability and growth. Some of these challenges include depletion of high-grade resources, which we are all familiar with, resource sustainability, high operational cost and market competition, volatility in pricing, innovative needs and capacity, strategic alignment, and skills shortages. So what are some of the drivers of innovation in minerals processing? While mineral deposits are generally becoming lower grade, complex, and variable in nature, the mining industry is responding to this challenge by innovating and developing technologies or process solutions that have increased efficiency and productivity, either by increasing production throughput, grade, or challenging some of the norms of processing. In many cases, due to cost constraints, the current focus of innovation in minerals processing is on increasing production rates, reducing capital and unit operating costs, and minimizing energy, water, and environmental impact. ESG compliance with the need to reduce the impact of mining operations on the natural environment is also driving how mineral processors assess the best solution and balance the risks associated with innovation. Other drivers or focus areas on pre-concentration technologies, investing in more energy efficient comminution technologies and circuits, coarse particle recovery, sustainable water usage. New instrumentation of sensors and advances in process control system configurations are facilitating higher levels of automation. This enables improvements in monitoring and process stability, which ultimately drive incremental change, facilitating improvements in performance. Therefore, the need for change in whatever aspect is the biggest driver of innovation in minerals processing. So what is this intrinsic relationship between research, technology, and innovation? Is it innovation of people that drive new technology, or technology that enables innovative ways of operating and discovering new solutions? Perhaps like the egg and chicken scenario, it's a combined effect. So just to clarify the terminology, of invention versus innovation. Invention is the process of creating something new, whereas innovation is the process of introducing something new that creates value, be it technology, change in flowsheet design, modeling and simulation, process control, or people and skills. In any case, both are important if new ideas are to be realized in practical engineering terms and used to generate wealth or value. Reflecting on the mining and minerals processing industry specifically, organizations need to build an innovative infrastructure, which includes the tools and relevant technology or people, culture, and processes to be competitive in the market. This is the continual process. So in order to create the sustainable success, it is essential to understand the variety of innovation approaches to determine the ones which provide the most value for your organization. As mentioned in the previous slide, the key is to understand that it is only innovation if the new way or approach works, it achieves the desired end goal, and it results in improvements. For example, if we are talking about efficiency or quality. So according to how well-defined the problem or industry need is, and how well-defined the solution and impact is, there is 4 types of innovation. There's basic research, which is the starting point of innovation by understanding the challenges within your market of influence and generating solutions for known or undefined needs. There's incremental innovation, which constitutes a gradual, continuous improvement of existing products and services. This type of innovation can provide continuous sustainability and prevent stagnation of operations. Breakthrough innovation or radical innovation is a step change approach, which is transformative, often creating a new need within an industry, market, or discipline. The success rate to shift and drive this type of innovation is often related to your organization's capabilities to create the right conditions for new ideas to be commercialized. Disruptive innovation is often the most well-known type of innovation. It involves effective use of new technology and results in high impact. This type of innovation, however, can have many challenges from personal to process operation. At any given time in larger organizations, a combination of all 4 types of innovation can exist weighted against the needs of the business to ensure sustainability. I have to stress that innovation applied conscientiously is a strategy for continued success within any business. So how do you go about implementing innovation? If innovation was that simple, every organization would be continuously innovating. The truth is that while some companies are well positioned to innovate effortlessly, others struggle profusely due to change from the older historical ways of doing things. The first step before embarking on innovation is to ensure that your idea or process solution and technology aligns to your business strategy, something that we take for granted. Innovation is not possible without experience and the right skill set. So it goes without saying that collaboration and cooperative research is needed not only with academia, but mining industries, suppliers, and OEMs to deliver on a product or service that generates a high and much needed impact. So to explain the innovative process graphically, which is probably the most easiest way to digest the process, one needs to acknowledge that most companies have some form of innovation funnel. So the funnel is wide at the front to capture potential ideas, and it narrows to a select few that seem viable. The intent is that projects progress from ideation stage through to design and ultimately to commercialization. With cost constraints, many companies then focus on the back end. They tighten the scrutiny as reflected by the sharp teeth, allowing fewer ideas to convert. This can be very risky as it doesn't necessarily lead to better ideas. It can lead to safer ideas, but it dampens innovation. Therefore, the funnel is better placed at the front end. Ensure a wide and constant stream of new ideas, which then can be tested and developed into prospective business concepts. Although the innovation funnel pursues a stage gate approach, The idea is to concisely articulate new ideas, thereby spending less time in each stage gate. So launching your project or technology in the soonest attracts customer engagement, and it's the customer who's going to tell you what's wrong, so you can correct for it. What are some of the challenges that you experience with innovation? Without even considering the bottom line, in terms of cost and potential for return on investment, some mining companies are resistant to change. The cartoon showcases this conundrum quite succinctly. Also, just taking into account the nature of humans, we tend to be impatient and we expect change to reap rewards almost instantaneously. Unfortunately, innovation can take time. As alluded to previously, lack of skills and innovative culture, the ecosystem that you work in may not be conducive to innovation. Also, for significant impact to be made, the entire value chain that you are intending to affect should be well understood. Mintek's Minerals Processing Division is effectively classified into 3 unit operations: comminution, physical upgrade or physical separation, or chemical upgrade and chemical flotation, including dewatering. To target relevant research strategies, each discipline focuses to a large extent on the current drivers necessitating innovation. So you will notice some common themes emerging, like process efficiency, scale up, water and energy reduction, and modeling and simulation. Over the next few slides, I will go into each discipline more deeply, focusing on the research strategies driving innovation. So moving over to comminution, and considering that comminution is an energy-intensive process, reduction in energy requirements and the need for higher throughput continue to be drivers in the future as ores continue to decline in grade. On the one hand, the current common flow sheet, which is your ag-sag milling, is energy inefficient, but it can handle higher throughputs, while the newer ones improves on energy, but throughput is lower. The future is thus an adaptation of the new mill, looking at improvements in addressing the energy limitation of conventional circuits. This by improvements in, example, stirred medium mill, which has the ability to use coarse grinding media to produce target grinds for downstream processes. Other challenges in comminution are that standard comminution bench scale tests require representative samples to generate data for design purposes and evaluation of comminution circuits. The reliability of small samples become questionable. Also, current power models do not necessarily take into account some of the key parameters, for example, charge PSD or lifter configurations. Mintek boasts industrial standard testing, lab and pilot facilities to carry out research and commercial testing. Some of our current research therefore focuses on development and validation of the mill power draw model, which takes into account the mill dimensions, the charge PSD, mill speed, mill filling and lifter configurations, and as I mentioned, testing of large and smaller samples to generate data required for design, instrumented facilities to measure and record operating and testing conditions, and partnerships with industry and research institutions in the development of energy efficient flow sheets for various ores. Moving on to physical separation, this group consists of a plethora of physical upgrade processes ranging from sorting to gravity separation, magnetic separation, and electrostatic separation. In the current era, physical upgrade has become even more pronounced, if not relevant, due to its lower cost margins of operation and ability to pre-concentrate material prior to downstream processing. The selection of which unit or flow sheet would deliver the best upgrade and recovery is not always that simple due to a range of alternatives currently available, as well as the complexity of ore bodies. Mintek, being a non-biased organization, is well positioned to test and recommend process solutions that deliver optimum solutions. This ranges from small batch scale tests to piloting, looking at novel process equipment and solutions, modeling of flow sheets, strategic programs in collaboration with industry, looking at expansion of resources and resource life. This looking at low-grade material, fines, reject stockpiles, as well as tailings retreatment. Mintek's flotation group has been involved in extensive process development test work for the flotation of PGM ores at laboratory and pilot scale. However, the current flow sheet has inherent limitations in that it may be complex, it can use non-traditional reagents which are even water insoluble, it predominantly focused on fine flotation, and the effect of water recycle is not clearly defined. So in response to the current industry challenges regarding low-grade material and tailings retreatment, we have tailored our flowsheet solutions to encompass novel flotation devices like column flotation cells, hydrofloat for coarse flotation, the MUP reactor, pneumatic flotation cells, which are performed at bend scale, targeting coarse and fine flotation. We have facilities that carry out testing from lab to batch to mini plant, pilot applications for scale-up abilities. So then how do you go about improving on innovation, and what are some of the lessons that we have learned here at Mintek? Well, you need to clearly articulate the market need and industry challenge. Define your focus area and work backwards. Ensure that the adoption rate is high when entering a market. Simplify your process or technology offering and don't prolong stage gates. Innovation not always has to involve a brand new invention or technology. If you are using existing technologies, components, or modifying a process solution in a novel way, you are innovating. In the instance of new technologies or process discoveries, know your competition as well as potential collaborators, as we don't exist in a vacuum. When collaborating, however, be cognizant of your company's legal policies. Human capital is probably the most important. Recruit the right personnel, or alternatively mentor and coach existing personnel by creating an innovative and creative culture that is aligned and diverse. Be prepared to step out of your comfort zone and encounter failure occasionally. Ultimately, change the mindset towards innovation. Lastly, I would like to end my presentation with some profound quotations on innovation, some of which are self-explanatory. However, if you reflect on the message of physicist Pollard and Einstein, the message is very similar. Basically, there is no end to innovation and creativity. We should embrace change. Steve Jobs was not successful overnight. His success was a rapid conversion of ideation into execution. So with this, I thank you all for listening.